Morning. It is an honor and a privilege to be able to deliver the first presentation here today. And really, in many ways, I get to set the tone for the rest of the conference. I don't take this lightly, and I just want to do the best work possible. My name is Tejas. That's pronounced like advantageous. Whether or not that's true, we'll find out at the end of the talk. Before the pandemic, I used to say another adjective that I can't say anymore, that my name sounds like. But I work at I actually run a company with no name, a consultancy with no brand, no nothing. It's still early stages. But what we do is we help other developer-focused companies have great developer relations. So we help with DevRel work. I'm excited to talk to Michele about this in the future. But that's not what we're here to talk about today. Today we're here to talk about front-end frameworks. And you know, the title of this talk, I will admit, sounds a little bit thought leadery and clickbaity. The state of front-end frameworks in 2023. I need to be fully straight with you. I'm not really an expert or an author of these frameworks or these libraries. I just have experience with them. I tend to stay in touch with what's happening in the industry. And the intention of this talk is that you would watch it, learn it, and maybe see things that you've seen people talk about, but you haven't had the time to play with yourself because maybe you're busy with work or you have other commitments. You may have heard of things like, I don't know, like signals or people hating on Tailwind CSS or whatever it is. And you might be thinking, what's this about? And really, this is just a catch-up. It's not an authoritative, like, this is the state of frameworks. It's more, this is kind of what's going on and what people are paying attention to, and maybe what the rest of us ought to pay attention to. Okay? Is that clear? Great, I see nodding. Appreciate the feedback, thank you. So with that, let's get into it. The first, if I think about front-end frameworks, if I think about front-end in general in recent history, the first thing that comes to mind is it's blurry. You know, it's the line between what we consider front-end and what we consider back-end is blurring and has been blurring for the past few months and so on. Because, like, if I think back to a time when I was a front-end developer many, many years ago, that just meant all the work I do is done in the browser. Be it CSS, be it JavaScript, what have you. If I'm using AngularJS or Knockout or Backbone or Prototype, Scriptaculous, whatever, all of my work was done in the front end. I didn't have to work with servers. I certainly didn't have to think about edge computing. What is that? If fast forward to today, and front end is blurry, especially with Node.js giving us back-end powers, we tend to do more of our work kind of in between worlds. I'm curious for everyone in the room, do you work with Node.js in some capacity? Yeah, that's exactly. If I asked you this 5 years ago, I doubt that would have been the case, right? So this being the case, we see more and more of an emphasis on what we call the BFF, or the backend for the front end. Some call this the best friend of the front end. Whatever you want. The BFF is becoming more and more prominent because it unlocks a ton of options and potential for us. Specifically, I think this is best illustrated maybe with a little bit of a diagram. I have TL Draw open here. Let me just pull that up. TL Draw, by the way, really great tool. I cannot sing its praise enough. Wow, I have a pre-designed slide. This is kind of what we see. Previously, the BFF didn't exist, right? So as a front-end developer, the work was kind of done here, and you interface with an API, maybe a database, a search engine, whatever back-end infrastructure is going on, you would interface with that. I, as a front-end developer, have experienced things where, and this is not to speak ill of either team, but I've experienced scenarios where my feature is ready from the front-end side, and I'm blocked on some type of API that isn't yet implemented. And anyone else felt this? Yeah, okay, a few. Exactly. So then there's this tension. Oh, I have this, but we can't ship because the backend isn't ready, and so on. And this is kind of where the backend for the front end gave us as front end developers superpowers, where you can actually just write some Node.js. You have a working server. You have the things. But then there's a problem of deploying it. I've had to speak to our internal DevOps teams a lot back in the day, where, okay, I have this Node.js service, now how do we deploy it? Oh, well, you need to Dockerize it, and then it needs to go on our Kubernetes pods and this and that, and it was never as straightforward as I run a command, it's live. until platforms like Vercel, Netlify, Cloudflare, etc. And now we've unlocked essentially a new component where this is a thing. You write your serverless functions, your edge functions maybe, or even full-on stateful servers, and we have, I'd say, more approachable ways to deploy them. This kind of conflates the architecture we're used to. By the way, this is a very hand-wavy, simple architecture. The point is not architecture. The point is illustrating the value of the BFF. So this is kind of where we find ourselves. And this is, in fact, the space Vercel, Netlify, other platforms play in, is how do we enable front-end developers to ship things extremely fast without being blocked by other teams or really anyone else, right? And so I think it would suffice us well to pay attention to, if we haven't been already, the essentially backend for the front end. If we ask ourselves, okay, what's the value proposition? What's actually happening? Did someone set an alarm? I heard an alarm. Someone set a timer. They're like, he's gone too long already. If we ask ourselves about the value proposition of backends for the front end, we see that you actually get really, really good routing potential. Back in the day, you would have a client-side router only, where you have absolutely nothing but a script tag and maybe some markup that loads JavaScript, and then client-side routing takes over, and you get your subpaths and so forth. But then if you copy and paste a URL to your friend, they just end up on the index page because the client-side router is the thing that starts the app. Moreover, I remember working with platforms like Netlify. Because of client-side routing, you would have a file like 404.html, and this file would come with a status code from the server with a status code of 404, but the 404 page would load your main JavaScript bundle, and you'd get your index route, and your client-side routing would take over. This is a massive hack with client-side routing. Client-side routing itself alone in isolation, I would argue, was a massive hack, because search engines would see a 404 status code and nothing else, right? The server, the BFF, gives us powerful routing potential where we route on the server side, and because we route on the server side, that is, we can go to myapp.com/route. On this route, we can do things securely. We can fetch data. We can render either an entire page or just components that belong on the page. We have more power with server-side routing. Second, we have rendering potential on the server. Server-side rendering is not new. It's something that we've been doing for a very, very, very long time. You're probably, show me your hand if you're using server rendering at work for your products. Yeah, okay, it's like half the room. It's pretty common. The thing that we are paying attention to now is a developing thing in the front-end world where you don't just render pages and ship them over your server, but you can now render even more granularly. You may have heard of server components, which is very much work in progress, experimental, and so on. But we have, or we're getting, the possibility to render tiny, like just a button. But you wouldn't render a button on the server because it's interactive. But you would render static, non-interactive content on the server that may be bulky, that may have large dependencies like date functions or some multi-megabyte thing. Do that work on the server and just ship the component over the network. So the BFF even facilitates this. And lastly, the BFF gives us the potential. I mean, it's a server, so you can respond to requests. So that's what a server does. But you can do it from wherever you want, including network edges. With the rise of things like V8 isolates and Cloudflare workers, which is a very lightweight runtime, you can run these BFFs very close to your users and reduce the latency. This is also something to pay attention to if we think about front-end frameworks in 2023. In fact, I've seen some really interesting early experiments where a web app is served from a pool of workers, each sending different parts of UI to create to stream effectively a final page to the user. I don't really know much about that, but I have seen that, and it looked very, very interesting in terms of shipping things fast, right? So we have all of these potentials, but the point I'm trying to make in the context of the BFF and why I feel like it's worth paying more attention to this year and coming years is because the conventional wisdom around how we build front-end stuff these days is just use a framework. I've heard this phrase a lot in the last 3 months, especially if you're starting a greenfield project or if you're growing an existing project. Most of what I hear is you need a framework. You have to use a framework. In fact, if we consider Andrew Clark on the React core team at Vercel, says this. Says if you use React, you should be using a React framework. If your existing app doesn't use a framework, you should incrementally migrate to one. If you're creating a new React project, you should use a framework. This is very clear. It's just like use a framework, use a framework, use a framework. In fact, React, that originally started as really a client-side library for making minimal efficient updates to the DOM, is increasingly becoming more and more server-focused. And this is a trend, definitely, that represents, I would say, the state of front-end in 2023. Why is that? Well, we just talked about it. We talked about routing. We talked about rendering, responding, etc. So frameworks are essential. Now, I need to be careful here and tell you, if you want to use React only on the client side, you can. You just won't probably get the full benefit of React, especially with some of the newer primitives. I'd like to actually, to make it really clear what frameworks save us from, I'd like to do a little bit of a exercise in code writing. This is mainly because I prefer presentations with code in them. The takeaway for you from what we're about to do is to just kind of get an appreciation for all of the stuff that Next.js Remix, etc., SvelteKit, others handle for us. So if we open up the browser, and I will I'll just open up my terminal. And what I want to do is show us the value of frameworks. So if I come over here, I close all this. I have a little app. I'll npx vite to kind of start it up. And we have here in the browser, localhost can't be found. That's a first. That's fine. I just need to cd into the right folder, npx vite. And now, it's a very simple app. I use the dog API. For those of you who haven't heard, dog.ceo, my favorite API of all time. I get a list of dog reads here. If I click on one, I get a link to a picture, and I see a doggo, right? So nothing really fancy here, but the goal is to show you the work that frameworks do for us. I think it's 5174. And this is a full client-side only React app. It's interactive and everything. But part of the drawback of client rendering, as I'm sure we can all appreciate, is you get absolutely no markup. You just get this. Search engines, anyone who can't execute JavaScript would see this. So huge problem. Thankfully, server rendering solves it for us. And what I want to do in our time together is implement just a very basic server that shows us some of the things server rendering and frameworks do for us. To do that, I will come over here. Let's just make this half size. And what we'll do is we'll create a little server.jsx. Very, very quick. We will import React. We need a function from React DOM. This isn't yet deprecated, although I don't know how long it'll last, but there's a function called render to string that will just take your React component, turn it into a string, and then you send it over the network. To send it over the network, we need Express. This is JavaScript, not React day Verona, so we'll just stick to the JavaScript. And of course, we need our component, so we'll import app from app like this. If we're interested in the general structure of the React app, we can talk about that. But I'm just letting Copilot kind of write this for me. I don't really care that much. App.get. So under the hood, this is kind of what frameworks do. Except instead of app.get/, you would read the file system. If you do file system-based routing, you do fs.readdir. Just for each path, create a route. We will render. We'll do, exactly this. And we'll do this. We'll app.listen 3000 and do that. This looks good so far. Your most basic server. Again, we would iterate through files on the file system if we wanted path-based routing. And we can run this. So I will, I actually need to also augment my build. This is just a client-side build. So I'll copy this. I'll delineate build client, build server, add a comma. Instead of index.js, I'm doing server.js. And we'll finish this off by saying platform is node. This should do it. So we'll npm run build here. I keep going to the wrong folder. npm run build. What? Did I save? I don't have build, of course. We'll do build, and we'll basically just run the client and server builds in parallel using this great command. Run p says run these two in parallel in order, and it comes from this awesome dependency, which if you haven't heard of, absolutely love, npm run all. So we'll save that, run it again. Can't resolve.app. That's a bit silly, isn't it? We'll get rid of that. Try this again. Great. So now we have a server that's about 2 megabytes, which doesn't matter because we control the server machines. But our client bundle is an entire megabyte. That's already a bit of a problem. But of course, there's compression techniques on the server that we can use and so on. So we have this. We'll just run node dist/server.js, and we should have a server. So if we go now to localhost 3000, res is not defined. This is why I usually write TypeScript. So we will do this again. And now, good, we have server rendering. But as you notice, it just gives us the loading. It doesn't actually become interactive. And that's because we don't have React on the client side. We forgot to hydrate. This page doesn't appear to be using React. No big deal. We'll app.use the public directory called dist in this case. And in our HTML, we'll actually send more than just a rendered app. So we'll probably do something like res.send. We'll add a template here. And we'll just do script. Gosh, this is really bad HTML, just so you know. But we're not here for HTML conf, you know what I'm saying? So we'll save this, and we'll put the HTML here. So now we're loading React on the client side as well, is what we're doing. So we'll rebuild, we'll restart, and now indeed we do have React on the client side, and in a little while, there you go. It fetches the data. It is fully interactive, right? This is not ideal for multiple reasons, but one of the reasons I want to highlight here is we're using render to string. While you can still use render to string in React on the server side, it's a bit frowned upon because it's a synchronous API and it blocks to render. So if you have multiple clients accessing your server and you're rendering components, or rather even your entire app to strings, it can block the event loop and make your server unresponsive. We need an asynchronous API. And for an asynchronous API, the preferred way is render to pipeable stream, which is an asynchronous API. By the way, this is just React because I'm familiar with React, but I'm wearing a Svelte t-shirt. SvelteKit, Nuxt, whatever you want, do similar things. So pipeable stream gives us an asynchronous API where instead of getting an HTML string, we get back a stream that can be piped or aborted. It takes a second argument of what to do. And what we want to do in this case is on shell ready, pipe to the response. So that's kind of Copilot. Oh, Copilot's wrong, not bad. This is kind of what we want to do. And what's happening here is when the shell, what is the shell? We'll talk about that. When the page is kind of ready, start streaming it to the browser. We need to make a distinction between the shell and the full app. This app is using suspense for data fetching. And again, this is something that frameworks handle for you. This is why you should use a framework. Because if we come over here to our app, what we see is, the markup you can kind of map to this on the left side. You have my breeds, the heading. You have hey everyone, the paragraph. And you have a suspense boundary that wraps breeds. Breeds is using suspense primitives like resources, etc. We won't get into that, but frameworks kind of save you from having to deal with this. It uses this to request the data. The shell on shell ready says, hey, when the suspense boundary is not yet completed fetching the data, but just has like a fallback, already ship that to the browser. Okay, and then it will. I'll just show you. It does something interesting here when you do render to pipeable stream, which let's rebuild that server and run it, and we'll reload on 3000. Notice there was a bit of a flash. So we saw the suspense fallback. And then indeed, the data is fetched, and we have it. But if we zero in a little bit on this, it's not interactive. This number doesn't increment. And that's because we don't actually have React on the client side at all. So the DOM update that you saw from loading to with data, that's all over HTTP streaming. That's a function of the server. And React does inject, if we inspect element a little bit, React does inject some markers into the DOM to kind of delineate this is the fallback, replace this with the actual data and so on. And it does also inline, this is a very long page. It does also inline some JavaScript that takes care of the update into the page. Anywho, let's go back here. We have this. We are still missing React. So to complete the loop, what we'll do is we'll bootstrap scripts, and we'll just include our little index.js bundle. In fact, it's just /index. So this basically says insert a script tag that references this file. And now if we rebuild and redeploy our server, we should have full React. And indeed we do. We have a development build of React. It's fetching, and it is interactive, right? So all of this work is handled for us by frameworks. And this isn't even complete. Like, there's tons and tons of things to do. There's path-based routing. There's server components. This was just like an entire file rendered to a stream. What if we wanted to have more granularity? What if we wanted to cache on the server? Caching on the server is way harder than caching on the client. And so that is pretty complex work, and that's why you should use a framework, because you get all of these benefits kind of for free. What I just did there could all be replaced with npx, like create next app, done. It gives you conventions, and that is the value. And that's why I think it's important paying attention to frameworks for now. The second challenge that we're seeing in the front-end framework world is updates. You've probably seen a lot of people talk about how React is not efficient anymore, how signals are going to save us from the heat death of the universe, all of this, and I think that's worth paying attention to. Fundamentally, the problem is the virtual DOM, right? I've heard a lot. I've even spoken to members of the React team who they say a lot of things and get in trouble, so I can't even quote them here. But the virtual DOM fundamentally, doesn't work the way at least I expect it to work in the context of change detection and updates. It like actually takes me mental effort to understand that when a state change occurs, everything in the tree under the component whose state has changed re-renders, as opposed to just the pieces that read that state re-renders. It's not fine-grained updates. It's from this point in the tree down, everything updates. People have noticed that this kind of makes React apps not efficient at certain points of scale. I think it still does fine for most of my use cases. And out of this came newer reactivity primitives like SolidJS signals and so on, which is something I think is worth paying attention to as well, just because it's kind of challenging the landscape. I have to say React's motivation is write once, deploy confidently everywhere, right? It was intended and is intended to be this declarative way of building user interfaces, where you don't have to think about imperative DOM updates. You kind of just say, I want this JSX tree on the screen, and I want it to respond to events and state in this way, done. You declaratively write code, and React's like, I've got you. I'm going to make this work. That's the intent behind React. That's always been the intent behind React. React has kind of failed in some areas to meet this intent. For example, with updates. For example, with useEffect, a function whom, and I mean this not offensively at all, but it's a function whose default behavior, if you don't read the docs and forget the second argument, will cause an infinite loop by design. So in some ways, it has introduced complexity where the goal is to not. I won't get into that. But I do think it makes sense to kind of model this reactivity part for you, just so that you're all in the loop. And really, the goal of this, again, is that in case you haven't had the chance to explore these in depth, you get some of that here, and then you're able to have the conversations you want to have that maybe you feel like you've been missing out on. Okay, so a quick demo for the reactivity piece. We'll go back in both cases, and we will CD into reactivity. SolidJS is the library that kind of pioneered this, and that's kind of how we'll look at reactivity. So I'm running on localhost 3000 a SolidJS application. This is a very meticulously designed application, as you can tell. I want to go to reactivity here as well. Just open the code. And I mean, it's what you'd expect. It's a counter that increments. Wow. Amazing. But this counter is interesting because if we look at the Solid code, this should look very similar to React. In fact, that's one of Solid's value propositions, is that it does give you code that looks like React. It's easier to write. In fact, Solid's reactivity with signals is not very new. Like if you've written Knockout.js a long time ago, you worked with observables. It's very similar. In fact, Solid was inspired by this. It's just when you combine observable, where you had to like subscribe and notify manually. When you combine that with the JSX of React, holy smokes, then you get Solid, right? Then I had to really control myself from saying something else. But then you get Solid, and then you get the power. So Solid works the way I would expect React state updates to work, such that I might as well just do use state here. I could even, if I wanted to be cheeky, do something like, there, haha, it's React. So Um, Now, if I click increment, notice this is a 10,000 element list. 10,000. Ideally, you don't even do this in production. You just have like a nice windowing mechanism. But this is a technical demo, so we go a bit nuts. This is how I expect it to work. You just do fine-grained updates on this part alone, and all of this is left unupdated. Solid takes a better approach. Well, better. I should be careful. Not better, but a different approach as well to this, where you don't need to co-locate your signals or your state with your rendering. You can kind of do this, and it works just as you'd expect. You could even put this in an entirely different file. You just go here and like, if you want to go really nuts, do count.ts and just export a destructure like this, and this is create signal. Create signal. Nope, so close. Create signal, and now we just import that. So we say counter is here and imported, and of course set counter as well is imported. This, and this should just work as expected, and it does. We could have like our use state somewhere else. Like Solid gives you these powers. The only difference really is you don't read a value, but you call the value, and that's because what Solid's doing implicitly here is when you call this function, it subscribes that part of your tree to an observable. To the signal, to updates. It happens under the hood. You think you're just doing a read, you're doing more than a read. Similar with writes, you're doing more than a write here. It will update the value and then notify subscribers. That's kind of what's happening. This is usually done through like proxies in JavaScript that allow you to do more than just get and set behind the scenes, right? That's kind of their value proposition. Okay, Solid can go a bit haywire sometimes, or rather I should say signals can, in the case of objects. So here we have .count as a property, and instead of this, we're going to do something like counter.count, and we'll set counter to an object where count is like this. And it's counter.count. So we have lots of counting, and this is fine, but if for whatever reason you decide, hey, we think it's better for our team to destructure objects as much as we can, you're going to have a hard time with Solid. If you do something like count as a destructure, and you do a read here, this will completely break your application. This will break your application a lot. So if we reload, it's no longer interactive. It's very easy to opt out of reactivity accidentally in Solid with things like this. And the reason for this, of course, is you're actually just creating a new variable here, a new constant that isn't really being mutated. But there's some footguns. That is to say, you need to be a bit mindful. Now, how does this work in React? I have a little bit of a demo here as well, just to highlight the value proposition of fine-grained reactivity. If we go here to React, npx next dev, I'm using Next.js there because I really, really like Next.js. Okay, so now on port 3000, we have React. It's a similar counter. If you've seen this screen, laugh with me. Anyway, this is a very bare bones React counter, and if I click increment, not only does the counter increment, but my 10,000 element list increments, right? If we look at the code, we'll understand why, and that is probably here. So it's exactly the same as Solid. We just have an h1 and a button and so on, and a 10,000 element list. The problem is React, when the state of this component changes, everything under it re-renders by design. That's just how it works, and this is something to be mindful of. Of course, the solution to this is to wrap the component in memo, and now everything's fine. So we will have a server client handoff message just because I was very, very lazy to not fix that. But now we have fine-grained reactivity. Look, just by that one function call. In both cases, and this is what I want to share with you, in the case of React or Solid signals, you will still have cognitive work to do. The cognitive work of, do I need to wrap this in memo, in the case of React? Or in the case of signals with Solid, should I destructure? How do I deal with computed updates to like you have to think in both cases. One is not inherently better than the other, okay? But they do have their trade-offs. The final thing I want to share with you, I hope I'm good on time. Am I good on time? Yeah? He's like, yep, okay. The final thing I want to share with you is bundle size is something perennial to pay attention to. But the conventional feeling is that we ship way too much code over the network. We do, and we always will. But that is something that also maybe changing. Anyone use Reddit here? Reddit? Okay. r/Verona. I don't even know if that's a thing, but if it isn't, we can maybe start it. Anyway, I love Reddit. I use Reddit extensively, and Reddit some time ago did a redesign where they have a new Reddit, and this was the saddest day of my life. Probably. I'm joking, it wasn't. As you can imagine, I've had many Saturdays. But Reddit, the new Reddit was awful. It was a new thing that they tried to be trendy and use React and so on. Gosh, I do not enjoy new Reddit whatsoever. So if we come over here to the browser, I just want to illustrate this for you a little bit. If we go to reddit.com, and maybe do it with a network inspector open. Oh wow, that's NSFW. Can we hide this? Anyway, this one is kind of useful. Let's just zoom in there. So Reddit, by default, loads 3.2 megabytes of JavaScript here, and takes 13.66 seconds to load, to finish here. That's tremendous. That's a lot. And I felt it. When I came to new Reddit, I absolutely felt it, and I hated it. Such that I feel like the Reddit team even knows people hate it, because you can easily go to old.reddit.com, and you get, I just breathe a fresh air sigh, not just because there's no shirtless man on my screen. But anyway, so this is an entire megabyte and a bit smaller than the new Reddit. And it does in fact feel, I mean, it took also faster to load. It just feels better. Why? Because there's less JavaScript here. This is also why, like, Hacker News, Y Combinator, is such a basic website. It feels great. They don't feel a need to revamp it, because you don't need to. So we ship too much code, and you know, it's not necessarily a good thing. There's a library called Qwik that is solving this problem exactly. Also, React server components solve this problem exactly. By offloading a lot of the rendering work and JavaScript to the server, the idea is you send less JavaScript to the client with React server components. React, although that's awesome, it does have inherent limitations with what it's able to achieve, because it was, you know, it's a bit mature and so on. Qwik is this thing that shows up, and it's just like, we're going to create code splitting as a first-class citizen, and everything is going to be code split by default. So Qwik is something worth paying attention to, because it always ships for any website 1 kilobyte of JavaScript around on first load. That's it. You will never ship more than that. It becomes interactive. You incrementally load JavaScript as needed. And I would love to kind of show you that in the time we have together. So if I'll leave React here actually, and what I'll do is I'll cd and go to Qwik. And we'll npm start. And what it's going to do is it's going to open a Qwik app for us. This is a counter. Let's also just get the code for this, just so that we see both. I did not want to open this. I'll open code dot. Right, so now we have the code for Qwik, and we have the Qwik app. It's again, look, another counter. Wow, counters are contrived but effective for very specific use cases. So this is a counter. There's some JavaScript loaded on this page. There's JavaScript for, actually, I don't know that there's much JavaScript. There's probably like Vite dev server stuff happening, but nothing more. We can confirm by going to the network tab and looking at JavaScript that's loaded. And in fact, there's a little bit of stuff here. I don't really know what, but I assume it's dev server stuff or Chrome plugins. We can actually even make it full size. Install hook. I don't really, anyway. I doubt that this is to do with Qwik specifically. Qwik will by default load no JavaScript and inline JavaScript. And then watch what happens when I click increment here. I want you to pay attention to this network tab, and we'll make it a bit bigger. So if I click increment, a whole bunch of JavaScript just loaded. And what exactly did load? What we see is we loaded something called routes, component, div, button, onClick, 8. And it does count value plus. But this was loaded after the fact. This was not loaded on the initial load. But I click here, and then it loaded. How does that work? So Qwik, again, the syntax looks very similar to React. This is probably something that looks very similar to React. You may notice just one marked difference, and that is the $sign. The $sign in Qwik signifies any closure after this $sign. So a function after this $sign, I want you to code split it out. This is Qwik signal to just send this somewhere else, and then lazy load it on demand. So in component $, this whole thing is code split out and lazy loaded when the component enters the viewport. Qwik handles all of this for us. Similarly, and I think this is the more impressive thing, is this closure is also kind of split out and put somewhere else, right? Increment, let's say, is put here. And this is a different file. It's not even the same module. And instead, what happens here in Qwik, if we model it a little bit, is it will actually, when you click, it will first lazy load increment, and then it will actually call it. It kind of does all this magic for you behind the scenes. And we really need to appreciate this a little bit significantly, because in the case that this is split out, it has no idea what count is if it's its own isolated module. Count comes from closure, from lexical scope. So in the case that this is inlined, again, if we do something like this, count makes sense because it can reference its enclosing scope. But if it's a separate module, it can't. Qwik has a compiler that responds to the $ and even captures lexical scope and all of this for you, such that you always only ship JavaScript when and if your users need. And this is a fundamental shift in the way we do interactivity, right? Because how we traditionally have done it is we just send an entire JavaScript bundle, all the click handlers, all the callbacks, or we code split by route, meaning we only load that specific page, but still all of it's JavaScript. Qwik says, no, load absolutely nothing until someone goes to interact with the page, and then make it interactive. This is a huge paradigm shift. I absolutely think Qwik has the potential to change the game here. It is a release candidate, so it's not yet generally available, but Mishko and his team are doing phenomenal work here. React does have an answer to this as well, with what is like server components is, I think, a more direct answer where you only send interactive stuff. But when you combine this with another concept in React called selective hydration, meaning something hydrates only when it's time to hydrate, you get similar Qwik behavior. All that to say, we're all moving in this direction. This is a trend for front-end frameworks in 2023. Okay, I would love to talk more about Qwik. I don't have that much time, but I do have a YouTube video for you if you're interested. That's where the video is. I'm tempted to say YouTuber nonsense, like be sure to like, subscribe, smash the bell. I will not do that, although I just did it. See, it's my trick. Anyway, what I want to tell you is there's plenty of UI tools available. I'm wearing a Svelte t-shirt, and I absolutely love Svelte. This is not an exhaustive list, but each of these has their own unique and special value propositions, and they're all super, super helpful for you. They're weapons in an arsenal and tools that we get to choose from. So the question is, how do you choose? And it really depends on what you want. For me, and I'm not telling anyone what to do. I can't do that. But for me, this is kind of the matrix I go off of, because for me, I really value people's time, and I want to give them experiences as fast as possible. So performance is pretty high up on my list. Qwik actually is measurably, significantly more performant than some of the others. I also care about how much JavaScript I'm shipping. And certain frameworks take care of code splitting and so on, so it's not that one is better than the other. This is just my matrix for decision making. And third is developer experience. I am not good at writing single file component syntax for Vue.js. I've written quite a bit of Vue, but there's cognitive dissonance. It doesnn't feel like writing JSX in React to me. Solid and Qwik does. So it's just about developer experience. It's about what you like writing. And you may not get all the benefits you want. It doesn't matter. This I think is quite important, and it's part of my decision matrix. With that, I want to just leave you with some takeaways. I just shared with you one takeaway, but the final takeaway is it really just depends on what you want. My intention is that I've been able to share with you a little bit more insight into things that you may have seen around the techosphere, to give you more of an understanding about things like Qwik, code splitting, signals, etc., and then go from there. With that, I want to say thank you so much for having me and listening to me for the past few minutes.